Two guests that are actually new for this group, and these two guests, the other guests will be introduced by Linus and Linus will do general introduction, and also there was some sort of moderation for the group. So the two guests I'm referring to right here, that's the Ronde Food. He's actually my business partner in practice. The business is called DJE.ONL, which is a sort of merge in two companies. One company is BOA, which stands for Building Perfection, and they do, for example, the ASML factories, chip machine making factory, and large structures like data centers all over the world. So, very interesting company. And Bart Sprenger, you have here, he is actually of the construction called Expo 2025. And that's interesting because that's our subject. So, everything we do will actually could potentially be very interesting for us. It's the beginning of the whole process, Expo 2025. It has to be supported eventually by the state. It hasn't reached that stage yet, so it's still just room for actually having influence on the direction things are going. So hopefully we have fruitful discussions with these two guys. They're only here in the morning, and we continue all day, as you know, so take advantage of their presence in the morning. Okay, I think Niels will introduce the others.
So, good morning everybody. On behalf of the tutor team, whom I just introduced, I'm Nilesh Biloria, also from Hyperbody, assistant professor, tutor, researcher, which is actually common for almost all of us. So I'll just introduce the tutor team very quickly. We have Henriette Beer, of course, Das Westerhaus, Anna Anton, Sarban Vidya, and Mr. Rao. So, it has been a very wonderful experience actually over the past semester dealing with a very, very exciting topic, which is the Expo 2025. As soon as actually when we were formulating the studio agenda, we were reading through the Expo 2025 website. And we said, okay, well, this actually does fit what Hyperbody is all about. It's also about extrapolating with future ideas. It's also about extrapolating and actually working together with advanced technologies, design techniques, etc. And actually we have now today, which is the D-Day, actually when almost all the students have been working extremely hard to produce technical, design, as well as philosophical sort of approaches to what the expo could be. The idea is also, a very central theme within this presentation is also going to be that we want to go a little bit away from the conventional notion of an expo when we start talking about countries and country-based expositions, but rather focus on the thematics. And these thematics actually range from, they cover almost all the spectrum, right? From the water to air to land. And this is an exciting combination in which the idea is to think about a thematic within which different countries will participate together. Also, one more thing, this whole event is actually being streamed live. It's also on YouTube. And also on this side, actually we are going to have a live Google Map, Google Earth update, which is actually interactively linked with the presentation of each group. The idea is as soon as the groups start coming up, the entire presentation there will zoom into their location and in real time actually inform the audience about where the project is. So I don't want to take too much time, but the idea is that the structure of the presentation will be such that we have 15 minutes of presentation within which the students will also demonstrate working prototypes that they have developed. After which we have 10 minutes of question answers and then we move to the next group. But the way it's also structured is it's also that we start with the water, which is actually a very interesting and very challenging kind of a context within which we thought of the expo. After that we move to air and then we move to land. Yeah, so there will be this mixture. And the first and the most important thing that comes to the mind when we talk about water is of course infrastructure. So now we are looking at different scenarios in which rather than thinking of bridges as connectivity elements, which can constantly, of course you can think of these bridges coming up, but what if there was no bridge, but there were elements that would connect in real time and actually as and where needed can be actually assembled. Yeah, and everything actually works on a programming layer as well. So everything is interactive, everything works pretty well. So I want to introduce the first group. And they will have 15 minutes to pitch their idea. And one more thing before that is that our groups, there's another student body of TU Delft, has asked us to kindly vote for the best project, because this project is going to be featured in a big exhibition. So Marco, our student assistant, will now hand over some forms, and you just have to fill up by the end of the presentation. Which one do you think is the best? So please, we start with the first presentation.
Okay, good morning everybody. Our group, we are Swarmscape. And talking about Expo, everybody will do knows the Expo area. And our group was particularly very interested from the very beginning was the mountains and the river, which gives great identity to the city and has an impact on it, but on the other hand it also cuts the city into two pieces and it takes a lot of area which could be used but can't be. So what I'm going to talk about, what our idea is, with all having that in mind, population will grow within the next years. So we have more people coming to the cities, we have more people in the cities, and just a great amount of people which we have to deal with. Thinking about that and also thinking about the expo, it means that we need to think of new types of infrastructure, how we can distribute and how can we handle these many kinds of people. And we just don't think that just building new metro systems or taking more water taxis will do the job or will solve our problem, or even build more bridges, which form sort of a ridiculous landscape, will do the job for Rotterdam. But what we think is that we need not to get away from these rigid structures to think in a more flexible way, in a more innovative way, and all these structures need to fit our today's society, which is fast, which is changing, which is interactive. Therefore, World Expo has always been, and hopefully the next one always will be, a place where to introduce new types of infrastructure, make room for innovation. And luckily Rotterdam had the chance, maybe in 10 years, to also address these kind of topics. And the relevance of talking about area, about water, and to make water usable is of big relevance, because Rotterdam can also be seen in a greater context around the world with other major cities which have to face exactly the same problems. Overpopulation with area is more valuable. And therefore, coming to the Expo area, it's the outline of the Maas River. There is existing connections, Erasmus Bridge, the tunnel, we all know that. And for the scenario of the Expo, we imagine to have the pavilions all around these riversides, and the Maas, in our opinion, can function as the main route for this experience. Therefore, what is needed, in our opinion, is a new type of infrastructure which makes it possible to have this experience of the map, which connects all the two different sites. And therefore, we introduce our vision of what we call Swarmscape. It's an intelligent, dynamic, and interactive system, which is a new type of architectural space, which combines the features of landscape and infrastructure. And I'm going to explain how that works. So we're working on a modular system, and there's a lot of modules in our vision. We have a big one, which provides area, it's rather slow moving on the river, and we have a small module, which offers connection, and is rather a passive one. So these modules, they have an intelligence. Swarmscape comes from the name of swarm, so it's half part of the word, which means they follow a certain behavior. So they're programmed not to crash into each other, they're programmed to match on the riverside, they're programmed not to float away, these kinds of intelligence. The other part, I talked about interactivity, is that these modules are interactive with the users which use them. And in order to perform that, because we have a lot of modules, we need a general intelligence, like a whole system which controls how these modules float over the maps. And of course, this system is influenced by the city or whoever the owner of this system is, which can also indirectly influence the people. And you have seen the first impression as a picture. This is a short animation who gives you the first impression in a video. So we're getting close to Erasmus Bridge, the city center. You see our Swarmscape areas on the left and right side to the riverbanks. And it forms some kind of interesting new structure, new kind of blur merge in between the rigid area and the water area. And how in particular these scenarios occur, how they happen, is what I'm going to explain next. Okay, so all these modules are under water. You can call it a zero stage. They have their intelligence, they float, all these verbs I just explained. And whenever our bigger system, which is filled by data, such as real-time traffic information, such as mobile information by apps, such as GPS data, like all these data which is available, but which is not being used actually for the architecture. If that data is captured, and if there's a certain amount of people somewhere on the river, the system will explain the modules to go there, to extend the area, and to move to these river sites. And this can be imagined as follows. So one module is already there, the second one starts coming, there's more coming, more modules are informed, and they try to form a rather rigid, rather combined youth area. But of course it's also possible that all these modules not just connect edge by edge 100%, but they connect also in a more free way and create in that sense a more dynamic landscape. And this is the big modules, they connect only to big modules, and then I spoke about we also have small ones. So also these small ones, they attach to the big modules and form also an additional, let's say, area at this end.
Okay, and I would like to explain how our models rearrange during the time, and I would like to start with the bigger models. So the bigger models, as mentioned before, are the slower ones, so they rearrange from time to time and based on the data that is collected by our global system, in the sense that the most popular attraction points would always have the largest number of the modules. And the small models are the fast ones, and their purpose is to form these connecting bridges. And they work by the rule that if we have a situation when two opposite attractor points detect a large amount of people, then a power line is formed, and all these small modules try to fit into this power line in the most efficient way. And it's also possible to have these multiple bridges in case we have a large number of people at several points of attraction at the same time. So this video will show how the smaller models would start forming a bridge, and you just can imagine that at the same time on the other side of the river it's the same situation, and these smaller models gather around and eventually form this connecting bridge. Also, important point is reaction to obstacles. And this video will indicate how this works. So in this case, we have a ship that is sending an information of its current position and its route that would be captured by the global system that would inform the small modules to change their position, which are in the route of the ship. And the important part is that these models would start blinking in red light so that people would be informed not to step on them before they disconnect. And the other rule is that when the ship passes, the models quickly go back to their previous location and form the bridge again. And as Swarmscape is as much as intelligent infrastructure, it's also an interactive landscape. And the first level of interactivity is the colors. And our global system basically, during certain periods of time, pick random colors for each attractor point, and the models that are active in these attractor points pick the same color, but each model adjusts this color slightly, so we have this constellation of similar coloring. Then, of course, when we have a bridge connection, a gradient color between the opposite attractor points is formed, and we believe that this would help to guide people through, so they could easily get to the other side of the river. Another level of interaction is the bending, and the main input for it is the frequency, the footsteps frequency. So our models have frequency sensors, and this allows our modules to realize when, how many people and what they're doing on the models. So if there's a steady frequency, the module can determine that people are standing or sitting on it, and in contrast, when there's a high frequency of footsteps, so that means that there's a lot of people moving on the module. And therefore, we have several bending stages, and these footstep frequency is linked with these bending stages. And the upcoming video will showcase several rules. So in this case, we see one person on the model, and we have some local coloring rules, which shows that even one person can make an impact for the environment. It leaves a trace of the light, and also the bended parts form a slight gradient from the middle part to the side ones. And we also have the rule that when there's no pressure detected, all the modules randomly blend, so we have this dynamic landscape. And in this video, we have a situation of a large number of people on the modules. So the coloring rules stay the same, it's just that the delay time becomes longer, so we have these big traces that also work for the guiding. And the other rule is that the more people come to the modules, the flatter the whole constellation gets, so our system is capable to deal with large crowds. And the bottom line is that just imagine the situation the next time you walk over the Erasmus Bridge during the night, and you see this unique, explorable, and constantly changing landscape, a combination of space, light, and multiple interactions between people and their environment, and between people themselves, because we believe that Swarmscape would actually become a new attraction point, a new meeting place, and a real urban scale art piece.
Okay, I'm talking now about how we developed this project, and we
almost work all the time simultaneously with prototypes. And we were inspired by the Harvard soft pneumatic soft robotic, that figure on the upper left. It's over there. Maybe I can show it quickly. It just works with this air pump, and it's it works like this. We try to scale it up and implement that in our actuation system. Yeah. So we did computer simulation also on that to see what happens if we use different patterns, different materials. For example, we compared silicon with aerogel, which is way lighter, and see if that bending behavior stays the same or what differs. And I guess it's now time to see the prototype. So here's a little touchpad that's 4 triangles of our module. And if you touch it, it will come up, stay there, and release. So we have silicon chamber hinges. They are inflated and directed in a rigid part out of any. This part is flexible and there are also rigid parts implemented to connect the chambers to the top surface.
Now I will try to explain some structure required to our big because most of the details are in there. It consists out of four triangles. These triangles are lightweight, pneumatic. The core is rigid, more heavy in that sense. The dimensions are about 8 meters by 8 meters for a big platform. And the part that bends up is about 4 meters. All of the module are pressure sensors. They collect data, they send this data to the core, and later this data is used to actuate all the hinges you can see. This is a section of our module, and you can see the lightweight structure with smaller air chambers to keep it floating, and a more rigid part in the middle with way larger air chambers. Now, like the kind of issue is like stability of this thing. So we calculated a bit on that. We have the point K, which is the keel, the lowest point. Point B is the buoyancy point, that means the water pressure. The point D is the gravity. And we have this imaginary point M above the module. And we want this distance between this point D and M as high as possible, which means a lot of stability. And our module is stable in like a flat and bended up stable. If the case appears that like only one side of the module bends up, we need this extra force F inside. That means connecting extra modules to it, so it becomes a larger level cable. For the energy system, we kind of want this air-based energy system. So the pressure sensors need to collect pressure energy as well. And we will combine that with solar panels. And we're talking 2025, so wireless charging between modules, between K and modules, which makes sense by that time. Now we talk about this little triangle piece, because that's where the pneumatics are in.
We need to wrap up.
Yeah. Okay. So
imagine a lighter surface of silicon, like the home module. Light pressure sensors are embedded into that. After that, the plastic part is put on top, covered completely in silicon on bottom and top. Then the prefab inflatable parts are mounted to it and to each other. They are also completely embedded in the silicon because you can really glue silicon. The air chambers work as follows. We have a central air chamber and several on the side. It's a semi-glass system. It redistributes air and only needs to be plugged up when we replace a little. We also have this connection part. So one of these silicon parts can be replaced by this wire and hook system. I will show a video about that now. So first bending. So into place, when it touches each other, the hinge starts bending up. And the next one is the connection part. So the hook opens, offers the wire, hook gets in, retract, settle.
Quickly summing up, like this soft pneumatic soft robotic parts are really interesting for architecture, and our vision of Swarmscape is just the first approach, and now we're implementing it for our built reality. And we believe with all the experience we made in the model, with the calculations, and also together with other people with their expertise, that it's totally possible to realize for Swarmscape and to hopefully introduce it in Rotterdam 2025. Thanks.
Okay, so let's open the floor for questions.
I just have to say, I love it. I think the question is following. It's almost perfect hyperbolic project. I think you represent almost in every page or every port what hyperbolic is about. So that's about. Myself very lightly. But let's look forward to the guests who have the nasty question. But I have one for you. And that question is okay. It's about modularity. But also hyperbolic. Movements we are part of, also by parametric design, where all the units can have all the units. So my question to you is the programmability, the modularity, is that in conflict with parametric design, the whole unit design, all the components are different, or is there a way to merge these two?
What our goal was first we needed to create a certain specific geometry that we just are able to connect. We discussed it before, and it's still an ongoing discussion for the time we spent. But it's not a conflict to parametric design. But of course, it wouldn't be that difficult just to increase different sizes, to work with different types of geometry probably a lot more, but I don't think it's
I think you make the right choice, but still it's open for discussion.
I don't know what the spending is for hyperbolic presentations, but I'm already quite impressed, so I hope you said the rest of the behind. I'm quite impressed as well. I see a lot of technical solutions that you found in connecting floating elements. I love child building rafts. I was wondering what I've never dared to take them out to the Maas River. Because there are a lot of restrictions, of course, you know, it's easier to say it's possible to use suggesting here because it's heavy ship traffic, the Maas River is very strong, called the Harbour Company, definitely absolutely possible to do. But Gale architects, they came up with solutions for giving back infrastructure to the cities, closing down streets. Suddenly people started using those areas and bringing out chairs, meeting, socializing, etc. And I think these modules make it for me a great solution. Or that's not no harm. There are many places in this city also where the water is just an open space. Give it back to the people who live around it, those spaces, public space, garden, social. I think it would be fantastic. So I think this is a brilliant idea. Very difficult to realize that location that you're suggesting is a great opportunity to public water space to people that see.
That was not a question, Bob.
That was not a question.
So a related question, because you guys follow during the expo and after the expo scenarios as well. So maybe that also links with this concept. Could you expand a little bit?
Let's say our vision is to introduce it at the expo, to present it to a greater amount of people, to test it, and afterwards, because it's a modular system, it can just spread out. So for example, we send 50% to other cities in the Netherlands, but of course it's also possible to just ship them to other cities, try them there. So the goal is to form this additional landscape. The nice side effect is also to form this infrastructure. And the opportunity, let's say, in the system is that we can have it at each of almost every water spot.
The question would be, did you check with the port authority what they think?
And the answer is no. Because we think for an export there must be some kind of exception for.
And the answer is also that we wanted to introduce this to you, and through you, maybe the exports. Next question.
Hello guys, good morning. Thank you for all the work and having me here. Represent the initiative of Expo 2025. I'm really impressed. The bar for everyone to come after. Looking forward to it. Actually, the expo is all about sending an invitation to the world to work towards a new future. That's what kind of it's also the essential of what we're doing, and it's about 67 large organizations in the Netherlands have said to join. So now it's going to enter our plans, not in Paris, where you have to bid, but in The Hague, where our cabinet sits, and the national government needs to decide whether to go ahead and make that a candidate for the World Expo 2025. This would certainly be material to showcase. The remarks by my colleague on the right are completely on spot. The inner harbors would be very suitable. The dynamics of people flowing to the city could be altered purposefully, so we want different dynamics. So I think it's really interesting. With the fact now that we have 10 years until 2025 to go, and we have the world market open for your area, we need one of them. Land and water are strictly separated, and one of them specifically the port authority and is really governing that very strictly. But there are nations all over the world in places in deltas where the dynamic of land and water are far bigger. So the dynamic of transportation are much bigger. Let's say that would be a future market, more dynamic deltas than we are in. What would be the technology that you are betting on that would need very strong cost reduction for this solution to be feasible? So you said something about power, but maybe you need another technology to have an exponential development and become more efficient.
Let's say the aspect we focused the least was the energetic aspect, as you say, and I think this first needs to be further developed, and then we try to reuse.
What needs further development?
Further development needs how we supply, how we charge our modules. This is a very big issue. And I think in the time of these 10 years, there's probably a peak, which is then a little time before the expo and can then be simplified, I think. Maybe also the manufacturing process, because the whole system is molded, like one big thing out of silicon. Maybe silicon can also be reduced to a less amount.
So we have a feeling or a gut feeling about the division of cost for the different parts of this?
Yeah, that's why we switched to this hybrid structure. So it's partly made out of a lightweight material and partly made out of silicon. And only because the silicon is kind of the expensive part, so we only use it for making these air chambers and that kind of stuff, and don't use that for the whole structure. That's kind of the idea of this cost reduction.
So you know where to focus in the next 10 years.
The nice thing about this discussion is it's already considered as a product that is ready to market. Actually, I like that idea very much. But concerning costs, I think there's not a real issue. I also know that not really, because it's floating things, we know that floating things costs, we know that electricity involved extra costs, we sort of know not of the costs, and that's about it. So it can be done. So I would say let's do it.
Yeah, I want to congratulate you. It's a great project. So I think it's very mature on many levels. So I appreciate your work. I go back to the question that Cass asked, and we discussed several times, because I think it ties me a little bit also on the question of costs. Because I assume that if you do research, if we would push this to the next level, and identify how different sizes and different positions and movements may require different geometry that would have to reduce, let's say, costs and make it more efficient. But this is the first point of to consider. Congratulations.
One last question.
Well, it's a compliment to me. I think it's really a nice proposition. I think that the said about the geometry techniques, the challenge would be how to change the geometry in inspired to be more or less inspired according to how we want to manipulate the sort of surface, about surface. So I believe that the potential for to create the information of the surface addressing conditions to the polarity. So would be
Okay, thank you. Okay. So yeah, exciting project. But now we move on to another project which again deals with water. But then it has a twist to it. So this project was of course about creating real-time infrastructures. But from this project now we're coming to making people aware actually of the water itself. What are the water crisis issues that are involved? How is it affecting the environment, climate change, etc., etc. So all of this is also bundled together in our next presentation. Okay, and the idea stays the same, 15 minutes presentation and 10 minutes question and answers.
Thank you. So we designed a pavilion that raises awareness for some of the major water-related problems in the world. The Netherlands is famous for their fight against water, with the delta reactive, the polder, and the dikes. And we show the world how to live in cooperation with the water. And it's something we want to show at the expo. We chose the RTM campus to raise awareness for what consequences people have in the disruption of the water cycle. And we chose the RTM campus because there are a lot of innovative projects going on there, and it's a place to show the world. There's also a good connection by water bus and water taxi for the pavilion. So normally it would take years to see some effects people have on the water cycle. But in our pavilion we want to create a landscape that has an immediate interaction with the people. So to visualize this concept, we looked at the water cycle in the different states. So to the states we connected the different problems. So for example, for drought we connected to vapor and excessive rain for condensation. So we create a two-part pavilion. We have the platform and the pavilion part. And the platform is made out of tiles that are able to move up and down. So we have a prototype showing the tiles moving up and down with linear actuators. These tiles are able to go up and down underwater as well. So here we use light to show the presence of people within the pavilion. We use pressure sensitive film. The pavilion part is on top to exit through enter the pavilion, and people exit through the exhibition space on the ground floor. The platform experience is based on three variables. This is time, the circumstances, and movement of people. And these three are all related. And the movement of people influence the behavior of the landscape, and the landscape influences the behavior of the movement of the people. At the first floor, people can hand a headset for extra sound effects to give an extra dimension to the experience. Also shoe covers if necessary, because people can get wet if they don't listen to the changing landscape. We calculated and estimated the amount of people at peak hour for the pavilion, and to keep the same density, the pavilion is able to switch off certain parts of the platform in order to keep the same density. So we see the visitors on the platform as water molecules. So in the different states, for example, the ice and melting in water, we want to manipulate the movement of the people according to the state they're in. So we want to spread them out evenly across the surface. So here's a little video of a storyboard we made a couple weeks back to show what how everything is interacting. So there is also sound. So this is the cracking of the ice and the melting into ice sheets. There are a lot of sound effects coming with it. This is on the movie that we can show it here. It's on the wiki. So here the rising of the sea level is simulated. And this is the evaporation of water, so people can explore and move around. So this is a state of vapor. Then there's excessive rain, it starts raining, to simulate rainfall. And this creates a river, and people have to move aside in order to stay dry. So people form smaller groups again. Okay, you can hear some sound. So this is a 3D animation we made using Grasshopper. Right next to sea level. The evaporation where people go explore. So it's a sort of game element. the free zone. Okay, so I'll now walk you through with some visualizations through the pavilion. As I said before, people enter from the top. This is where they get introduction through the headset about the subject and the theme. People can enter the pavilion at any time because it's a continuous loop. So you can start by water and then continue and do the complete circle. So, for example, this is the cracking of the ice. Cracks of ice will shoot underneath and in between the visitors, and the cracks will grow into smaller sheets of ice. In the right top corner, you see an overview of the whole pavilion of these sheets. The tiles can change color, and together they show an image of the location in the world where this problem occurs. So the rising of the sea level, people have to move, and the island will shrink, and have to move to a bigger island. This is the evaporation, where people have to explore and fill in all the gaps and evaporate the water. For vapor, we recreated the cracked floor of the ground, and we show the image of the Sahara Desert, which is growing. The tiles are quickly moving up and down to visualize the rainfall and its splashes of water. And then, for example, in Bangladesh, there are a lot of problems with floodings. So we simulate the river flooding, and people have to keep walking and interact with the flash point. The freezing of the river, this is the only positive part of the experience, because this is the ice is growing and expanding. But then on the last stage, we remind them the vulnerability of the ice. So if people are standing too close together, the ice will, the tiles will go down, and people have to distribute evenly across the surface. And then they exit through the exhibition space on the ground floor of the roof structure. And this is where they get extra information about what they have learned and what they have seen. And also what they can do in order to help reduce these problems and consequences.
So now I will elaborate on the actual design of the building. So we, in the very beginning, we already decided to go with hexagons because they suggest more directions than, for example, square. So we also decided that the whole building should consist of hexagons to go for one clear style. So we started with a normal grid of hexagons, and then we distorted those by using attractor and repellent points we found in the RDM work. We actually reconstructed a pier over here. So this is the covered part of the building, and this is the platform. So now I will tell you about how we came to the final shape of the building segment. A normal building would consist of 2 walls, 2 floors. This would be easy to make a proper structure, but we actually wanted the people to enjoy the view of Rotterdam and the harbor. So we would need to open up those walls in many places, and it's like 20 meters in sections, so it will create giant moments and forces on the remaining walls. So we decided to go with a core structure. So we have this core in the middle, and then the 2 cantilevering floors. But if we only would have this as a structure, it would still have way too big moments. So we decided to add a second structure underneath the floor, which holds the cantilevers together. In order to also create a nice, comfortable place, we decided we needed to add some glass facades to some parts of the building. So that would protect the people from wind, rain, and waves. Instead of going with like the glass triangulated panels, we decided to go for more standard curtain walls, and this is actually because the shape is way more clear this way. Over there it's more like a dome to us, so that's why we chose the second one. We have a clear visual connection between the upper floor and the exhibition space. This is because the core is made hollow and transparent, and this also allows daylight to enter the exhibition space. Alright, so this is a diagram of the structure and how it works. So we have these cantilevering floors, which actually are part of a three-dimensional truss. So you have these trusses in every direction, and these are connected in the middle by a ring, which is reinforced by steel cables. And in the middle, it distributes the forces by a truss ring so that it holds the whole structure together instead of collapsing downwards. So this is an axiometric drawing of the structure. It's consisted of all triangles, and it's eventually paneled by aluminium composite panel. And then here we see an exploded view of the structure. And as you can see, the foundation is a layer of EPS in a shell of concrete, and then it's anchored to the floor of the riverbed. So this is a visualization of the interior and the section, and you can see that when you're in the pavilion, you're surrounded by water on all sides.
Okay, I will say something about how the modular tiles work. It actually consists of a lower part, that's the floating element, the pontoon. In the middle there's this linear actuator, and on the top you see the light emitting tiles. So this is, we designed the tile to be very easily put together. So we hope that one person can actually, or two people can build this tile together and just drop it into the water and connect them to each other. So the maximum height of difference will be 600 meters, and in steps of 200 millimeters each time. We want to use plastic from the oceans to create our tiles. So by making our pavilion, we also make the ocean a bit cleaner. In order to keep equilibrium, if there are people on the platform or not, an option would be to use a submarine system. So we pump water into the tiles when we pump air into the tiles when people are on top of it. So there will always be a perfect height. And there's an option that can be very expensive, so we also looked at another option, and this would be to create a fence, a border on the platform that keeps water inside. The tiles are very easily replaced if something breaks down. So the waterproof element on top can be very easily unscrewed with just one screw on top and replaced quite fast. So we can keep the interactive space functioning. So we use two systems to track people. One system is a force-sensitive film on the tile, and a backup or safety system with a GPS tracker. So there will be no dangerous situations when the tiles go down. That's what we hope. So we have an intelligence system as well. The computer tracks where people are and redirects them from low density areas to high density areas, so people will move around the whole platform. We want to give the people also a personal experience, a memorable experience, but make it more personal and by evoking emotions. So with sound effects and with high density scenarios, we can give people a more memorable experience. After this expo, the tiles can be easily transported and put together in other places, like you can see here. And our structure will be a ferry station, so people can wait more comfortably at the area campus when they want to go to the other side. So yeah, that was our presentations. Thank you. So if there are any questions, we'll like to answer them.
So, yeah, questions?
Dynamics, the system as an export product. I think we also fit so well done. During the presentation, so the smaller components, somehow raised with respect to the level of mass. That's your final choice. So it's not the real water, it's not the real water. It could be the real water, it could be the real water, but it's not the real
Maybe now I have several questions. My first question is, what was first in your idea of the idea of raising awareness for what?
We heard that actually we try to use the same time, because we know that there's no real place to wait for the ferry at the RDM station, so students have to wait outside in cold conditions. And secondly, we want to address the problem of the water cycle that people cause. So we try to combine those two things, and it actually happens simultaneously.
Because to me, I think that the product of the tile that we designed, they can have a very good purpose. But I think the idea of creating awareness, that's a little thin. That's a thin theme, I think. You're turning a really big worldwide problem into a sort of game. And I really doubt people get that awareness from the situation they're actually in at the moment by standing over their tiles and feeling their space shrinking, etc. So I like your system, but I think you should be very careful with using it for awareness in this model. Maybe I know that the cost line is very much in the time. I think you really I think I'm not sure, I think Amsterdam we created a sort of light ceiling so that people understood could feel that they were about 10 meters below sea level. I think here in Delft we're below sea level as well. Something like this is really frightening to read. I really like to read But I think it would be a great solution. The other thing you mentioned is using it to get on and off ferries. Could you investigate that as well?
Yeah, we made glass panels on places where the ferry is not safe.
We didn't put glass where the ferry is docking, but we didn't do a lot of research about what is needed. But we need to make some adjustments after the expo, so such as a ramp for bikes or stairs to go up to the platform on top. Yeah, it needs to be further elaborated.
Yeah, you probably took the ferry at the ADM campus sometimes, or well, any ferry. It's still a 200-year-old system they use, I guess, or maybe a 500-year-old system with a height difference between the docking platform and the ship, and they throw out a plank, and that's it. So I thought that this would be a perfect solution for something like that. So maybe that's something to investigate for the Expo 2025.
So congratulations, because the UK Pavilion in Expo in Milan, that was held this year, was the winner of the contest of the most strong concepts. With let's say the UK had the strongest message to the world. And their pavilion, have you seen it?
Yeah.
Well, that's great because the pavilion had a message about how bees are becoming extinct and by that posing great risk on human health. So I really think the concept of a strong message is a winner on exhibitions as we know them today. I think I agree. I was mentioning myself on the platform, and contrary to you, I thought, wow, this is some experience, so which you won't forget. So I think that's a very strong concept, and I think it's very good to have a real interaction with the pavilion, because that's what's basically non-existent at this point on world exhibitions. So that's, I think, really strong. I have my questions about the principle of no leftovers or the reuse opportunities. But I think the suggestion of a flexible platform is a good one. If you Google for Ampelman, that's a Dutch company which was founded 100 meters south of here in the civil engineering. They had a good problem with getting onto drilling platforms. So they found a solution for that, and it kind of has a big resemblance with what you propose. So in terms of future use, it can be, could you elaborate a bit more on what your ideas are with that?
Okay, so first we had the tiles could distribute across the world, and first of all spread the same message, but it could also be a different program or a different experience. It can be rented by companies or by governments, and there's a wide range of possibilities with this system.
Have you thought about applying the system without water? Because if you make it waterproof, it can be in public space easily.
No, we didn't follow that.
I would, my recommendation would be, I think you have a strong story, but the strategy for circular use could be more elaborated.
Okay.
Well, I think about the message, I think what you also showed was the beauty of it. So you showed the beauty of iris, the beauty of being separated by some result. And it's not only a threat, it's only a beauty. It's also a beauty. I think one of the challenges, actually, for these, what is called world problems, is also how to cope with things in a positive way. Yeah, so not defend against it. And I think that message you were able to send across.
Yeah, I agree. I understood that the whole system, the interactive system, works very well. So I think it worked out well. But for me, it's unclear why you need data structures. So I think the part that is interactive stands on its own and is powerful. So the data structures seem to be added for no reason. I think this is powerful enough. I have only for that. And I have to use mass. Why do you have this?
That's why we had to do because we need a layer of water on top of tiles, like the moving tiles, and then the platoons would need to be underwater, and then they would sink.
We made a solution with an air pump from underneath inside that pumps air, but in a realistic scenario that can be very expensive. So we suggested to show two solutions. So this is with the Maas River itself, only like each tile would have to be pumped air into on certain moments. So it's more a cost thing. So we showed two solutions today, and we have to do more research to see if we can do this cost effective.
Yeah, thanks guys for the good presentation. Before if you want to interact with that on they're actually on our inside. They have their test really there, so if you're there, just go by and say. The funny thing is I haven't seen you around Christmas period, and after
then you came with a structural solution, and again, now you come up with this solution, so you have the ability to sometimes come up with a new solution which so describes in a positive way. I really appreciate this indeed because the second option, because it relates to a more simple structure and a more stable structure. But going to your superstructure of your big elements. I think 2 weeks ago you showed me the structural principle, and with just small modifications, I think it was quite a convincing story that you gave me. But there's 2 things. One is, what still do you think is the main issue with this? And the other thing is the combination with the glass. So do you use the glass as structural elements? Yes or no? And maybe also elaborate to the rest of the group, how do you come up with the sizing of the elements? What was your idea with that? Not saying it's right or wrong. I will explain that later maybe, but
the glass is not structural anymore, and we didn't calculate like the ultra-elevated truss or something.
Alright, so again, it's surprising possibly because it looks quite peaceful, and if the glass is not structural, I would say it's not required because you do have a quite strong structure there.
Yes, like glass is not more for comfort.
Yeah. Did you think about detailing then? Because still, what would you say is the main issue with a cantilever like this?
Yeah, like all beams in structure are in different directions, like
Yeah.
every single one, I guess. So we have a proposal detail, I guess. We made that, but we didn't have that checked yet. I didn't put it in.
I think the most difficult part is how all the beams come together. So we have to design like each element will be kind of different. So we would have to use like 3D printers or something like that.
I think it can be a rather good structure for all systems. But yeah, take into account that there's a lot of reflection and detailing the glass. That's important, but very good job.
I think we need to intervene a little bit. If I look at your proposal, I think it's over-structured. There's a lack of design, because basically what you do is a very traditional approach, like a base, you have a structure, and you think about structure, nothing works there. So from that point, I would have to see a detail, because we could easily have taken the component library as a structural component actually to form of stress, and that would be the whole structure. It would be one tenth of the cost. It would be more effective. It would be much more effective design. So basically, there is a need also not only to look from a structural point of view to this design, also from an integrity point of view. Everything integrated. Do you integrate different elements where the stuff of architecture is made, so allowing the form to repeat, or to go and that.
Just one last comment from me. I think what we would really benefit from is also start looking at the tile in itself, because remember we also have discussed ways in which, let's say, ideas of mist that could actually end from the tile, ideas of how the surface itself could actually mimic the idea of the roughness of the snow, etc. I think those all add to the human experience. So this experience design somehow needs to actually go one notch up in our case. But otherwise, I think the concept is fantastic. So great, good work. Thank you. So still sticking with water.
Ja, misschien dat iemand
Yeah, do it. Did you win? So basically showing that screen, so maybe just about the...
Okay, so the next one, we still stick with water, but now we look at a completely different phenomenon. So the idea of understanding what actually goes into purifying water itself. And this we're trying to look at from a very different point of view. It's not about seeing water purification plants, but actually being inside the water. And this group has a completely different approach to how they want to expose people to this experience, which is also coupled with interactive installations and form finding methodologies. So, floor is yours.
So in the 2015, the pavilions have to design as the So in the 2025, the World Expo is under the changing current themes, and where the ambition is to focus on the environmental challenges and to bring it to the economical opportunities. Our pavilion is a water purification hub. As a whole, it's able to produce a drinkable water. Water sanitation and scarcity is become the global crisis of the next 10 years, and we think that the demand of the water consumption will get increasing more and more, and the nature itself can no longer regenerate the state. So now we are in the urban issue environment where we try to create this water treatment plants where it's almost inaccessible by the public. So for our pavilion, we want to design something that the public can actually use it, and also use it as a didactic qualities to see the importance of the water purifications. So in this case, we use plants, bacteria, and charcoal as a main element of purifications. And at the end, we wish that our pavilion will improve the current conditions of producing water and cleaning up the water, and in order to provide solution for the future.
Yeah, then I will explain a bit about our home finding. As a purification pavilion, the water and the people are two very important elements. So we want to use those two flows in our design. At first, we use the people flow to generate a field on this side. But you can see that people will just go directly to the destination where our pavilion located. They don't have any strong relationship with the other part on the side. So we use the swirls of the water to shuffle the people flow. And each swirls could resemble, let's say, one place where some events could happen. So in this new pattern, we generated a new landscape and a new people flow on this side. Thus people are more engaged with this side. And our pavilion is also one part of the landscape. You see people flow line. That's people from the landscape to the slope, then to the entrance of the roof. And the water flow line also introduced some natural and environmental elements to our pavilion. Then we created our pavilion programming with those two flows by intersecting, paralleling, and also overlapping. Then here comes our final form. And we also put some physical model to analyze the relationship between the form and the flow.
So actually, when people actually can walk from the landscape through these bridges directly to the roof of our pavilion and enter from the center. And beneath the skin, there are several spaces that are all integrated with each other as a whole system. And the whole tour can actually divide into these elements, that the four main spaces and the transition spaces between each other, and entrance and atrium as the start and end of the exhibition. And so people actually follow this circulation to walk through the whole pavilion and experience the water purification process. And also the water go alongside this circulation, that the water actually flows alongside the water for the visitors. And if you look at the section, you can see that our pavilion is half beneath the water, so we have better access to the water, to get the water in this area. We developed this structure system because the big span and the big spaces in this pavilion, so the vertical support are very limited. So we divided all the structures into primary and secondary beams, and some part use curved columns, and some part need to use this cantilever beams to make that cantilever part possible. And for example, at this corner of the pavilion, that the yellow part shows that the beams that directly link to the vertical supports, and others beams may not directly link to the columns. And compared to the other references that we find that can purify the water, we hope and we calculate and we hope that our hydrobody pavilion can at least purify 24 cubic meters of water per day. And in order to achieve that 24 cubic meter water, that each space have to have some part of have some spaces to contain some amount of water, and also use the theory of the venturi pump to make the energy efficient of making the water flow and rise and down in the whole pavilion. And that is a little model that shows how the structure and the water system that embedding with each other, and the light can actually show the people how the water is flowing in the pavilion.
We're going closer to the pavilion using the four phases that you mentioned. Here's the first phase, the process, and this is the center stage, and this is our center stage over there. will stop all the purification process with the charcoal. So let's go into the user experience part. And here's the whole user. And yeah, here's our whole four stages that contains every purification layer started from then goes to the vector stage and go to let's say finally goes to charcoal stage. Actually every stage we did some research into that and try to say that everyone is one stage of purification process. For the plant, they get rid of something that is hard that is condensed in water. And for bacteria, it resolve this problem. And for and then it goes to that finally goes to charcoal. We finally have a triple layer. And first let's start with the interaction part in the plant stage. Actually, we're trying to develop a stage that can make people feel that they are going through the purification process at these different scales. For the process, actually people can see the very beginning condition of the water through the tubes connected these two plants, and we choose three. One standard purification plant in Europe as our purification plant here. And when we have approach, the two can be illuminated and people can try to see that how this water looks like at a reference scale. And yeah, here's some simulations of how this material is applied and how the installation is working. And then we go to the second phase, the bacteria phase. We do bacterial diversity and some physical research, in the bacterial principle. Actually, we're trying to do two different scales of interactions. One is people as bacteria, and one is people as this interaction with bacteria. And here's the first simulation of showing like how people behave as bacteria. The bacteria purification mainly by they attract metabolics to them. And here when we don't realize this concept as when people act as bacteria in the middle of the bacterial part. And the projections that simulate the metal iron is attracted when people are moving. Like they are attracted to bacteria. And when people just stand still, they behave the opposite way. And this one is the second skill that we're going to express. And this is how it's people as human skill to visual how bacteria is working. Actually, the purification bacteria can also generate electricity. And when people are going through the fire, they can also get signals so that the bacteria which translate the electricity can lighten these fibers, the optical fibers, and the bacterial light can be transferred to the end of the fiber and can be seen as people. This is how technically this process is working. Yeah, and then let's go to the the step phase. And here's the simulation of how water is going. Actually, fundamental research said purification is the slowest process. And this is written that this part provides a better possibility for people who go very close to the purified water at this stage. So when people are going through the great here, the number of people has been reached. The water can be pumped out so that people can see that at this stage how is it looks like. Yeah. And this is what we've done to create this area as a clear in that setting. And finally, let's go to the opposite. And the problem has very traditional and it is useful. Purification layers. Okay. They are realized. So usually, people are aware of using them as purified drinking water, but sometimes they didn't notice that these things actually need some shifting. So here, we want to create a shifting assignment actually for people to help this charcoal brine in the purification process. We have the up and down component, and people are attracted to the component when the charcoal brine needs to be replaced. and the component actually is leading people to the replaced chocolate bar, and people can just hold the handrails and help to replace. You can see that our plan here is forming a circle, so that when visitors finish this circle, and one chocolate bar can be pushed out and can be examined to see if it's need to be replaced. So this is the first impression, but people are going very close to the material. And yeah, and sorry, I think there's another solution. Yeah, sorry, I think there's a rendering has been made, but actually I tried to create a kind of a fiber that can make people like they are water molecular, somewhere up here. They're going up and down and traveling through the space so that they're experiencing how they're going through the porous charcoal structure. And this is, let's go to the atrium space. Actually, from the very first beginning, we see that plant are purifying the dirty water, and now we go to the atrium, and here people can get drinkable water here from the drinking fountain. And here you can see that we create a wall, and people can have their use bottles or cups to insert them in the wall. Because sometimes people always have question like, if I really want to drink the water, it has been purified from the natural sources water. And here you can see that some people really can do that. And sometimes we want to raise people's awareness about drinking water and nature condition. So that's the whole story of working through the purification system. Yeah, and for the post-expo, we plan to our visit keep working as one museum or monumental things here. And we're going to have a landscape, as we mentioned in the form generating part, can keep working also as one part of the purification and also as one part of the urban. So that is our hyperbodytudelft. Thank you.
Okay. Questions, comments? You didn't get it?
Set the tone. Maybe to be allow me to be very critical. Is that okay? Is that okay? No, I think something difficult about disease, I would say, that you use metaphors to actually try to get to the point, but you never reach the point before actually reaching it together. So what we do, we mix metaphorically, we insert into architectural structure, which is necessary, very traditional as well. I would say. And they never touch each other. So in stark contrast with the other presentations, what we say, you are you are actually enrolling in between. You are never part of it. And then you solve that problem, try harder and harder, and more harder you try, the harder you get from. Actually, this point what you introduce many details. Actually, to show your point, this is what the most efficient way to do it by walk. No, you're looking for the largest possible detail to show. I can see the point when you do it. If you do that, you stretch it so much, it may become part of that process. So I understand what you're trying to do. But because you are blocked by you somehow don't manage to do it. But you really want to. So I hope you can accept this as your point. Otherwise, I leave for next year.
Well, I have two things. The second one is a very easy one. The first one is a little bit compared to what Cas is saying. I think we're trying to show with the pavilion and this whole experience that it is possible to filter water and make drinking water out of a river whatsoever. And I hope you know the live straw. Have you ever heard of the live straw? It's a sort of big straw. You can stick it in any water you see and just start sucking. and the straw itself cleans. I think they have all the techniques that you have in this quite big live straw, in that small straw. And it's a very strong representative thing of, oh, it is possible with techniques to purify water and directly drink from a dirty river. And this to me is also like you're showing a huge live straw, so I share that comment. But my biggest question is, why this location?
Actually, the two locations start from the Axon, from Axon. This is
You were referring to swarms of people going to that place. I do know the location, it's close to Schiedam.
Yeah, Schiedam.
It's not really swarming with people over there yet.
Yeah, that's why we don't do that. With business in like Shanghai and Milan, and actually sometimes it becomes one opportunity actually for the city area. And for Schiedam, actually this is the boundary between Warren and Schiedam, and it has budget. Not a very bad traffic condition, and this is a very huge underline, and there's like previously residential fences running. I think we think that there's potential, and we just want to make it transform.
Do you know there's another area the other way, completely other near the Greener Bridge. It's the former drinking water purification area of Rotterdam, and there's some beautiful, more sculpture-like. Quiz. That's where this region purified the water. Have you ever considered that to be a location that seems to be much more logical? Have you considered that location or not? So you have to do a better research. It's absolutely worth a visit.
And that's part of the expert.
Okay, guys. Well, I think you've marked your design and your proposition of a fine expedition combining infrastructure with a nice thing to do. So if you look around the city of Rotterdam, water purification 150 years ago was done through a system of waterways through the city, because there are lots of diseases in the city that said, well, the municipality said 150 years ago, well, we need new water system to clean our city. But also we need new places to live and have some leisure time in the city. So the city was growing, and we need new places for the rich tradesmen that Rotterdam brought forward. And they created a plan of waterways by the city architect Rotterdam. And he proposed that a Heemraadssingel, I don't know if you know it, but also Noordsingel, and a lot of waterways which are now very beautiful park-like places where you can also live very nicely, etc. So you combine infrastructure, civil works, water purification with something which is more than that, urban life, living, recreation. Your case started in India, I think, right? So we showed a film, a short clip about water purification and the need for it in India. Have you done any more investigation on what functions would be suitable to combine your water purification straw XL, that's very big, your water purification machine in India? So what kind of functions could you combine your design with in the place where this proposition originated from, in India? Or am I not wrong about that?
It's not particularly about any location, but it's not in India, but I just want to show that the need for the expo is to share the idea to the world, right, to the different nations, so it's not about.
Okay, could you give a reference on any thoughts of how this would be in let's say your own home country? What kind of functions would be able to combine with this machine you made and integrate in the city? Well, because now it appears to me as if it's pretty much a pavilion in that sense. So we have a world exhibition and it has a pavilion, so that's kind of logical. But it could be more than wandering around and seeing stuff. How could it be more of a real interaction with the city and be a pavilion? So maybe next time you consider to start with the next step in the life cycle, and then design the way backwards towards the exhibition. That would be my suggestion. But otherwise, I make it for a proposal because the municipality of Amsterdam will be delighted to know that they're at the center of research and technology. So.
I think there have been steps taken to integrate the different stations, so I appreciate that. I also appreciate the detailing of the experience. Actually, there are many points which I like. It is true that further integration and combination with some functions that come from the city and technical comments, city would help a lot the project. I also want to point out of the site, I think it works really well with urban independence, which already becomes an important part of the city and it's close enough, so we were hoping to establish a connection there. But otherwise.
Quick question then, or remarks. With discussions over the last, say, weeks about integrated structure, I would like your point of view on the shape that you had, and finally adding on the structure instead of integrating the structure where you design your shapes. How do you think about that?
I think that actually, honestly speaking, the shape that finally gave us a very big problem when we deal with the structure that I think that if we think it at the end, if we start thinking integrated with the structure and make it more technical and to make it way more clearly to show how the structure is integrated with all the things that I think that's the one problem.
Okay, thanks.
Always bigger when you talk about structure. So basically, I think there's also here this delamination between what you want to do and what you actually do. But what you show is columns, beams, trusses, secondary structures. If you would have asked my advice, I would have told you no beams, no columns, no secondary structures. What you model is a shell structure. It's not beams, columns, etc. So you model one thing, you do the other thing. And it is again about trying so hard to do it right, and by trying so hard to do it wrong. So we still have something to do.
But yeah, I'm not going to give my comments right now. I think we have a chat later on. But wonderful presentation. Good work. We do one more and then we take a short break. Yeah. Because the next one. so now we transition from water, we get to air and land together, yeah? And as you can see, of course, needless to say, they're dealing with drones, but innovative ways in which what drones could actually do for the operation. So the floor is yours, 15 minutes.
Hi everyone, I'm Lucas Omnipresence. We started by looking at the theme of the expo, and like any World Expo, it deals with current social and environmental problems, and this is getting more intense. And we saw that the answer that people try to provide a lot of times is passive sustainability solutions, so low tech, low use, reuse. And we felt that in the 21st century we have to use much more technology and active ways to solve this, or to help solve these issues. And in recent decades, a lot of technologies are coming through and being innovated, and they're being applied in a lot of other industries, so the car industry, the avionics. But in construction, we're still dealing with a lot of waste and not using enough of the smart strategies and parametric tools that we can use. In parallel, we concentrated on the concepts of what technology is in the 21st century. So collective intelligence, robotics, adaptation, or flexibility, and self-assembly structures. And from all of this, we came to the analogy of a swarm, like you heard before. And a swarm is basically just a network of a lot of small elements that are quite dumb by themselves, or they can't quite do much, but together they form emergent behaviors, and they can do interesting things. And we thought the concept of the Internet of Things, which means the digital integration into everyday objects, can be very useful here. And like a building is made up of thousands and thousands of bricks, for example, we wanted to create something that is made of thousands and thousands of smart elements that have digital capabilities. And how can the structure be flexible enough so that it can really extend the capability of the built environment? It has to fly. And we came up with the concept of using drones, basically quadcopters or other flying mechanisms, to create a unit that can interact with other units. And today, as you can see, drones are used in quite limited scopes, so taking photos, videos. Tomorrow they might help relieve some disasters, help gather some data, but what's next? And then we looked at what is the use of drones today in architecture. So here you can see the example of this project by ETH Zurich, that they carry bricks, right? So the drones carry bricks, but they're not more than that. And then there are various other 3D printing technologies and robots that move around and extend those capabilities, and even fly to make a bridge out of wires. And so for Rotterdam, we saw the whole site itself, the whole urban center, as our site. Because we want to be everywhere, we want to provide these services of structures on demand by using these smart swarm elements that will communicate not only with each other, but also with the public, and especially the expo users and visitors. And we created 4 typologies: a wind protection system, a rain protection, a main space pavilion, and urban furniture. So we started by mapping locations of other groups, pavilions, then the paths between them, selected 75 potential sites, and to those sites we created, we measured the wind direction and speed, their size, their intensity of use, and then we decided which sites fit for which typology, which can provide a main pavilion, which can need a lot of rain protection, etc. And an important thing is that the consideration is, okay, can we really do this? Can drones really fly across the city? Apparently they can, because even today, drones have, they can fly a certain speed for a certain amount of time to cover large distances. So even today, if they use 80–90% of their energy for interaction, they can still fly a few kilometers across the city, and then they can recharge. So it's not a problem, actually. And this is the impact that we have on the city. The whole city itself is actually our pavilion. Now we'll zoom in a bit on a section of the city to show you some various scenarios.
Here we are moving to the other tab. Actually, scenarios what we are doing with the drones. Now, to speed up a bit the presentation, I will say that I will use the term of MMU, the shortcut we were using for the multi-purpose mobile unit, which is our one drone. And all about the actions that the scenarios are running around the concept of recharging, that it has to land somewhere and to gain the energy, and relocating, which is traveling around. So here we've got 2 basic actions, which are the actions on the way, which are happening in this tab.
So we've got the trip guidance, the speaker system, all of the actions around the emergency situations like lost people finder, and the guide which is interactive around the city and can guide us through the city and show highlights and interesting places. During our research, we also thought, okay, we've got changing environment because it's an open air, so we also take into our consideration the changing weather factors to optimize the trip between the partners. The users are communicating between the MMUs through the mobile applications. Therefore, they can decide what is needed. And also in this way, you can develop into the presentations via the virtual reality or the voice commands that you can ask the drone, the MMU, to do something for you. Those are the actions that are happening in the air on the way. So I'm gonna just show you on those examples what is happening there. So right now we've got multiple social networking platforms, but we actually see that we miss some authenticity. We miss this contact that is happening between strangers, which are visiting the expo. So this might be a social media platform that is connecting people together, then they can meet each other. Another action is something that is developing more into the personal assistant. For example, here in this situation, a child is lost, and you can ask the assistant, the interactive MMU, to look it for you. It will scan the nearby faces of people around, and it will find the lost person. Also, following this topic, we've got all of those things that are connected to the crowd management, about all of the flows of people going, like millions of people coming to Rotterdam to visit the expo. So to avoid waiting in the queues and all of those obstacles, we can develop some speaker system with some notifications to the users to guide them and to inform them about the conditions of weather as well. And the more personalized look might be a focus into the amusement instead of waiting in a queue. So you can enjoy a trip with your personal guide that can show you the interesting places in Rotterdam. And last but not least, we can also think that the big swarm of flying units which would flow around the city can attract people's attention. So it can also encourage to take a part into the expo experience. Okay, right now I'm gonna move to the on-site scenarios, the second half of our scenarios, which are happening when the units need to fly somewhere, sit there and recharge. But on the way, we can also develop the interactions with people. So this is our main pavilion. It will contain a lot of the MMUs, which we'll explain more later. But it's growing and it's adaptable according to the interest of people. When people are really into workshops that are happening there and they really need the information, they are attracted to the design is growing to host all of them. Here we can also imagine the scenario which is happening on smaller sites, one of those 75 sites, which two groups of people are coming together, and the MMUs are scanning the site. They are asking people what is the desired function of this site, and for example, here people decide, okay, let's have a seat there, let's chill out a bit, so we can order the furniture. More people are getting encouraged into this scenario, and they're also moving to this type of interactions. Here is also the example of the interface that you can decide which type of furniture is desired. Another action is to actually building structures. In this case, it's a wind shelter, which provides the shelter from cold Rotterdam wind. But on its way, it can also entertain people, because the inner layer of the pavilion is built out of interactive MMUs, which can display videos or can be a great setup for show or performance. And the last scenario which is happening is a rain shelter. The rain shelter works on its way that it can build out a dome that is hosting the people, trying to prevent them from
from rain, and also entertain them during the rain. I also want to mention that all of those algorithms are based on scanning the site, scanning all of those 75 parameterized sites, that the structures is built around the groups of people, so they don't need to adapt into the structure is adapting towards the people. Okay, and I will leave you with this impression that we can move into the simulations.
Thanks. Next one, we want to try to show you a bit how the stacking into an actual pavilion will happen. Here you see, for instance, people sitting on the furniture, and in the back you see the rain pavilion with the interactive visuals on the inside. And next, we have a video. Yeah. And it's a simulation of how the space-filling shape will stack, because this shape will stack into a filled shape. This is a top view where you can see how the whole pavilion can suddenly, if that's needed, disappear in thin air. And here you can see a transformation in between the wind pavilion and the rain pavilion. For instance, when it starts raining and it forms around the people. And it does this layer by layer. You see that very clear here. And then in the end, you see them coming in faster because it has to, because otherwise it will collapse. And then you see the second layer coming over it. This is, for instance, the protective layer, but Paul will show you that later. And here you see how the actual when the MMUs will be in the sky, they will actually also give it a performance, because it will look very like a swarm. And yeah, so the presence of the drones will constantly be there in the whole city. And this is the last one where it collapses. And now we'll go to the technical data. We will zoom in a bit more, and Paul is going to do it.
Yeah, I will guide you through the technical data here. This is the section of the main pavilion. Here we want to show that we're using different subspecies of the MMU, so that we can perform different actions. Next up. This is another section. You can see that there are some layers also, and inside activities for people. Yeah, and first layer is the structural layer, which is composed of the structural MMUs, which first ascend into a skeleton, to which after that the inner layer and the outer layer is attached. We estimate that, for example, the main pavilion will need around 9,000 MMUs of each type. Which, for example, the rain pavilion, which is much smaller, will use around 3,000. Yeah, so we have 5 different subspecies. So the top one is the interactive one, the right one is the moving, the outer layer one, on the bottom we have the structural and the urban furniture one, and the scout is the last one. Because of their unique features and abilities, they compete with each other and perform certain tasks in a swarming relation. And yeah, let's zoom in a bit. This is the structural one. It comes in 3 different route thicknesses. It has only one coaxial rotor, because this one is actually much more powerful. But less agile, and in this case we don't need that. Our structural analysis was proved us that we are able to hold loads with these elements up to 100 kilos After that, they might break, but this is the maximum load that will occur per one element which is sitting on the ground in the bottom of the structure. Next one. Okay, this is the seat. It's basically the same as the structural one, but it has some modified joints which are able to house slots for straps, which provide seat for people. Also about the locks, because how do they connect to each other? Theoretically, we are talking about electromagnets. You can see those spots here on the vertices. For the presentation, and for the prototype, we used simple magnets because obviously that's more easier. Okay, and this is the structural analysis of the seat. Also, it is able to hold up to 100 kilos. And the membrane, this is the outer layer. It has some panels that provide shelter from rain, but on the other hand, it has some openings so that the wind can penetrate the structure. Why it penetrates, but not entirely. It holds some wind, but we will explain that later. Why is it needed? If it has to,
also need to wrap up soon.
If it has to fly, it opens, so the truss can penetrate the frame of the drone. And yes, this is why we need the openings in the frame, because it has to recharge. When it recharges, the propellers adapt to wind direction. Also, the panels are in a transparent option. This is an interactive one. It has speakers and LCD touchscreen, or OLED touchscreen to communicate better with people. And this is the Scout one. It has a wind meter to inform other subspecies, the whole swarm, about the wind direction and wind transfer. And the last one is the analysis of the rain shelter. Here you can see the stresses in the bottom of the structure, which enabled us to iterate each structure so it's thicker on the bottom and works better. So the loads are smaller per one element. And now we'll go the prototype presentation.
Great. So let's wrap up just this. Yeah, let's start.
Previous presentations, let's go for it. Okay, that's why. I mean, this is creating the universe, programmable. Oh, it's not all existing. So that we are in the universe. This is an architect. And we are here. You know, another quarter, the programmable quarter, changing this word. I would think that's convinced of the need of the car, I have to say. I think that it's a bit people don't like, it's not necessary. So not so much related to the individuals, related to the drug. So I think there's a movement there. But the basic, the basic concept actually is absolutely firm. And really gives us a feeling that interactive architecture actually is the key. Yeah? Dynamic systems is the key to a new approach to architecture and to actually be expert for we know as the architect. So thank you for this presentation. Very good.
Well, guys, to have an example of what you mean in visual ways and also more tangible ways is always very convincing. I have one more question. So let's say if you would go to the J programmers this afternoon, start a company for young promising CEOs, first interact with the CEO. The second one would be to decide what would be the biggest issue to solve as a company. What is the biggest issue to conquer the world with your product that you need to solve?
Probably there are two issues. One is safety, because this is a very dangerous product, as we know from the test. We have some.
You had 5 people.
So that's probably an issue in the regulation around that. And the second issue is probably the optimization of the stresses and structural capabilities. So we didn't have that much access to structural software, advanced one, that can really push this a step even further. And probably there's room for improvement there.
But in this case of informed adaptation, about all of those connecting the data and passing them through the connected and swarming behavior, it's already possible. So we are really, it was only convinced about the idea.
But maybe on your last question, what critical issues that you want to address with your business case? I mean,
it would be maybe something less focused on the expo, but in that, still in that spirit of providing some service to urban environments that can create spaces that are for social activities and for events. Yeah, every temporary structure that you can think of can be created.
Well, the first bit was I wrote down the friendliness. I mean, this picture is, I find it interesting but daunting at the same time. So I think friendliness of the swarm is really something to solve, and it has to do with safety, but also with, it should be something to serve
people. So it should, I think the service-oriented bit is really something to think of. That was about technology. I was wondering. I mean, the drone
bit is already there. So which is it hardware or software? Which would be your business?
Yeah, because actually we made a system, so it's much wider and broader than we now experience. Because we had the task to make a pavilion, and so we did. But the strongest part of this project was actually creating a system which can do multiple tasks. And we actually only gave examples of a few, and it could do much more. And we made it with expectation of the development of technology over the coming 10 years. So we expect that it's only possible in 10 years, yeah. So the strongest part in my eyes is the software behind it, because it's making a system that works together and is the internet, but then in reality. So
I also think that about the friendliness, it's I think a generational thing. So the generation of today, I don't think they'll have a problem interacting with a flying robot with lots of internet. So it's maybe scary now, but for people who are growing up now, it's totally fine.
For example, the friendly example of the emergency drone which was built in 2000, it was already like bringing light to people. It's not about something which is dangerous.
I only had a remark, and probably a generation gap that scared the shit out of me. This whole swarm of buzzing things, knowing everything about me and knowing if I need adventure, etc. Exactly, that was, especially with animation you were showing.
It felt very much like Alpha-Nito with the roads. It was the word settled. But I think the biggest reason that it scares me so much is that I think it's feasible. I think it
in a very short time. And what I like, I mean, I think I have 1,000 questions, technical questions, legislation questions, etc. But you see here is sort of ultimate form of Kaskol's disappearing architect. The architect is really there when you meet him. And maybe this is a form of the ultimate hyperbody. So I will not ask the 1,000 technical and other questions. And just that this is a fantastic idea. It's very feasible, I guess.
I think that was our main goal, to actually build a prototype that will act in the way that it can present that it's actually doable. That we can, even in those few months, we can actually reach this level that we can do something which flies and can form a structure. And just regarding those things about the regulation, etc., like I think right now we are holding the smartphones in our pocket, and this is much more quieter and doing exactly the same. So we just have to embrace this problem. It's already too late for it.
I would like to congratulate you because I remember our last discussion where I was challenging you to prove that it works, and I have to say that you proved that it works. I would ask you because when you're talking about the structure and the dome, people consider that you have actually the layering implemented in such a way that basically some of the domes are still there moving. Because then you have dynamics, so they are still hovering, and only at the moment where they click together.
You can see that actually in the simulation there. That when they're sitting, they're slowing down, and to the very last moment when they are all there, they are hovering in there.
Okay, and then basically the next comment with respect to the dynamic you're making in the city. Of course, the challenge is going to be people are moving, and most probably it's not a problem so basically you move slower and slower the more near it comes to a person, so that it can stop eventually if necessary. So that's not a problem, but how can you prevent that you're not going to be able to build this structure because there are too many people moving. So I think safety is not a problem, but rather how can you achieve the goal in a dynamic system.
I think it's also about the whole mobile interface. It's all about the interactions with people. Like, for sure, people will have to be prepared, and Expo is a great event that you can actually practice it. That it can be even something like a symbol of the Expo, so everybody has to be familiar with the concept. And maybe this is the thing that, yeah, we have to learn somehow the users how to use it.
There's going to be basically a dialogue. You need to establish some kind of dialogue.
Right now we establish the dialogue via the application, but it might be also, like I mentioned, like the voice command, like please move a bit to the crowds, or please make a space for the pavilion.
In this case, I have seen a feedback in the design and I want to say something. I want to ask if you are considering having an active been structurally active as it forms the structure and maybe this is a wider discussion, but I'm really interested if you can make this step towards a structurally active building.
We don't know. Give us a few more months to try that.
Previous discussions about the hardware or software. I think basically you're designing a spatial way behavior and the interaction between people and things. So it's neither hardware nor software, but the spatial implications, and it's actually working inside the dynamic system and actually make design decisions using developing such a system. So that I would say would be more appropriate what is actually what you are selling. When you are selling a whole new system, how to behave in the whole system. And this is the spatial configuration, which is for the static for architect. So this is the dynamic form of being an architect.
Alright, so I think it's quite clear these guys already have the entrepreneurial spirit because they are fighting back. They are even after cutting some 2 or 3 fingers, I think they're still alive and actually rooting for it. So good luck, you guys, and excellent presentation. We are very happy to have you guys. And we have now the last presentation of the afternoon. Of the morning. Now heading into afternoon. Okay, so let's set it up again.
Oh, please, let's sit down.
So, okay, so now from the air acrobatics, we have to now move a little bit into... Well, I can't even say it's actually rooted in one place. That's not with this new project that we're seeing is a new take on what can compost actually do for you. How can you create generative landscapes on the fly. So this is another new innovative concept that I speak about in 15 minutes.
Okay, hello. Yeah, we're Waste to Space. What we were thinking about this expo is the tagline is environmental challenges to economic opportunities. And for us, we try to look what the expo itself will bring. And what it will bring is 50 million people, and that is 50 million people in Rotterdam using a lot of things, they're eating a lot of things, and while they're preparing for the future, they will be actively throwing away a lot of stuff. And we were thinking about if we're going to change something for the future, we have to start at the expo. So, looking at the waste that goes on today, you will see that around 64% of this is something that can be broken down into soil, it's compostable, and 1/3 of all food in the world right now is being thrown away. So that's a huge, huge resource.
both energy-wise, economics, and of course, we're losing soil, we're losing ground. The water level is rising. So what we're doing is we're doing something called hot composting. It's usually when you do composting, it's called cold composting. It takes a lot of time. So what we're doing is we're pulling it down to 2 weeks with informed technology. If you have all the right parameters, you have the right temperature, you move the air continually, you have 50% green matter such as food, 50% such as paper, it's called brown, you get the perfect compost. Yeah. Also, we're looking at what can we do with the rest of the stuff. Well, plastic is thrown in a huge amount, and what we're doing is we're taking that plastic from the visitors, we're having the interaction of the visitors, they're throwing away their things, we're collecting it in our pavilion, as you will see. It's being sorted out, and we're 3D printing from the plastic with filament. So what we're having these components, which are informed, they will supply all the right conditions for this compost. And they produce an enormous amount of compost and soil, about 75,000 liters per week for the whole structure, as well as 1,000 kilos or tons of plastic per day. So what happens is we have all the visitors coming, and they're throwing their stuff, and it's being sent up with pipes into this huge structure that we see, which has all these components full of compost being made. But we also thought that we can handle so much waste that the Rotterdam municipality could actually dump some of their excess stuff with us instead of burning it. So this would be one of the components. Essentially, it's like a gyroscope structure. So you have this this component with the compost in it, and it will rotate when it gets too warm. Because if it's too warm, the bacteria will die. So it will feel the temperature and it will rotate. And it will also handle air intake to handle the humidity to keep it on the right level. And here you can see it will change in color as if it gets too warm. Here it will start spinning, and as the temperature drops from the core going to the outside, it will also change in temperature. So we'll have this experience of having different stages of compost and temperature being displayed. 72 degrees, that's the optimal compost.
Thank you. Those are the compost components, and they're the main part of our actual pavilion, which will be a temporary structure, which can be taken apart and then put back together again. And it will be put in a certain place, and according to the size of the place, it will stay there for 1 month or 3 months or 5 months or 9 months, or whatever you need. And then it can be taken apart and brought to another place to create a landscape there. So the pavilion itself is a tower in which you can walk and experience what's happening here. Can you go to the next one? So in this tower we want to show what is normally invisible, which is a huge infrastructure of waste and garbage making and regulating. So part of those components are plastic components and part is compost components, and all of them are changing color all the time, and also they are rotating in gyroscope, which creates hopefully some sort of metal sound. So when you walk in, you hear those things flipping. You see them changing color, and you will experience what you normally will never see. And then when you finally reach the top, all of that noise is gone, and all the colors you can't see, and you see the landscape it created before. So yeah, here you see in plan view that in the ground floor you can put your waste in. Then you walk up the ramp around that first part, and then at the top you can go in and see components from inside. So the structure is temporary, it can be made all from parts. So we first make a foundation, which is necessary because of the weight of this whole structure. Then we put on the structure first, the middle core and the staircase, then the whole tower is made. And in the end, when it's gone, we still have the foundation left, which we leave to make a greenhouse on it, so that small plants can grow there before we put them into the compost landscape around it. This is a view from inside.
Right. So, what can this tower generate, and how can it be beneficial for the city, and how can it, what will be created from all this waste in the structure? It can be applied. The structure can be applied on different sites in the city. And for example, for this example, we have chosen a square in the south of Rotterdam, which are surrounded by, which is first of all surrounded by big roads with heavy traffic and quite a lot of residential buildings. So, to actually get the compost and the plastic out, we're proposing a system of drones that the plastic is generating the landscape in the same manner as a 3D printer do today. It's gradually over time builds up the landscape in layers, and later another type of drone is filling the landscape with compost. So the landscape generating process are informed by different parameters at the site. For example, noise from the road, so it creates this noise barrier at the site, and it could be like positive aspects of the site, that is football pitch. It takes that's data that the drones will consider. It can be sun direction, it can be movement. And over time, this will grow and grow, and more and more compost will come in, and the growth will make the landscape bigger and bigger, and create this sort of new typography, which could be almost, which feels almost like it's canyons and hills and stuff that's maybe missing in Rotterdam at the moment. So yeah, and this is an elevation indicating what kind of spaces that could be created in between, which so let's talk about a little bit more now.
Yes, so this is the landscape, and then when you look up closer, you see that the walls are not just straight white 3D printed walls, but they have a pattern on it, run so that plants can grow on it perfectly. So is this? No. Yeah, can you go on back? Yeah, so this is inspired by tomatoes that are hanging upside down. That is done actually quite a lot, and then the soil doesn't fall out. But for the plants, it's great to grow on because the water falls down and comes into the plants very easily. So we wanted to create a pattern where the soil doesn't come out, but plants can grow out of, which is, for example, this four-line pattern. And according to parameters where you want green and where you want it to be close, for example near the roads you maybe want it to be close, but near the greenhouse you want it to be green, we can inform this pattern by where it makes little holes and where it closes it off. And then you have a natural set of parameters which defines the plants that grow the best. So at the top, for example, it will be drier than at the bottom, it will be wetter. And also the pressure at the bottom will be higher. So different plants can grow in different places. And now we will close up.
Yeah, and to sum it up, of course, with this new addition of soil, while in this great city, which is gonna be more and more underwater, that's for the rest of the cities, we're also proposing that this new addition of soil could be used to reclaim or use some of the water, and that would be an inverted algorithm to the on land, that the pathways would instead be formed by compost instead of being surrounded by compost. So have this negative space in between, which is the water. So that might look something like this in the end stages. And yeah, so yeah, this is our vision for our look, and also of course having these huge, for example, tomato plantations would probably benefit the local residents. And it's a very direct way of showing how. It's one thing to hear that, yeah, yes, we should recycle or whatever, but now you're actually seeing what you throw in will go back to your community, and I think that's something very strong. And hopefully people will see that. So yeah, that's it for the compost. Oh yeah. Well, since we're 3D printing landscapes, we just made two quick, small 3D printed landscape to show how it could look.
I like the concept, composting and spreading, because the probably very close to this project. There are some flaws in between. How do you start this process? How do you go from one stage to the other? And again, structure of the tower. I mean, once you have these units, this is the basic. This is the structure. If you go add another structure, the whole thing. This is the structure. This is the structural material. That's the way you think about and use them. Then it comes to the building. Designing a building often seems to be the most difficult issue, because we always hold that it's a difficult idea for the building. So if you are faithful to your concept, you can do that. Forget about structure and apply the new building on a built structure. The other flaw we see here is how do you bring the material into that structure? How do you get it out of that structure?
Yeah, now that you mentioned it, we had a diagram earlier. Well, basically, as I tried to mention earlier, it's like a tube system. So you have this central gathering point which collects the material. Then it goes through this middle structure, just goes up with flexible, retractable tube to each component, which is also how it's taken back like that. So it's buildable.
But that could be part of the basic model as well. Certain models could move, bring the empty model, bring one down. Because why would you go up all the way to harvest? Much easier if the model comes down. Press over the side. So you could have things differently there.
Yeah, we were on that track earlier, and then as the design changed, we went from that. But since we've landed in another design now at the end, yes, maybe that would be something specific.
I do have a question. The tower you were mentioning, that was not for the regeneration of plastic, but just for organic and non-paper, right?
That was for both, yes. So some of the components can, we can put a slicer in and it will collect the plastic instead.
Yeah, and then I saw the perfect temperature is 72 degrees Celsius, I guess.
Yeah.
Why didn't you consider also using the heat that we produce in the process also for the environment?
Yeah, well, we were assuming that we would use some of it for powering the structure itself, but I don't think we made it clear enough. Of course, yes, of course, we should use the pretty big amounts of heat that's being generated.
Okay. And then my final question would be: did you also estimate how high the hills in Rotterdam will be in 1 year, 2 years, or 3 years? Because I have no idea how long it takes to form a landscape like this. And is it closer to 1 year or closer to 100 years?
So these kind of landscapes, which is about at most 3.5 meters in height on a site like this, which 130 by 65 meters, it would take 6 months for a tower of this size to do.
Yeah, well, then it's obvious next question.
Yeah.
When will it stop? When do you take the tower away?
Yeah, first of all, we were thinking in the time span of the expo for this, of course, but then the question becomes when the parameters should stop. For example, when does the landscape become not something that we experience, but an obstacle? So that would be thinking in that long term, but of course bring another level that we have concentrated on for this, since we had the given time span at the expo. But yeah, that's something to think about.
I think I would like to make a comment, which is, because since we also know your product, I think there's a big problem with the way you present the project. Because there are different parts to it. There's also an information part which talks about where in this context and therefore what kind of a landscape pattern is going to be generated, based upon which is calculated the height and size of the structure, and therefore the composite. So there's this relationship which is actually completely missing in the presentation. You don't see that. And therefore the idea of what sizes of the composed structures and where from the community you collect them and then put them up. So it's a completely closed, and I mean, I shouldn't be speaking this way, but I think it's really important that you make your project really clear in terms of all these. Otherwise, you miss the point. And suddenly the whole focus goes on, okay, what is the ornamentation of this wall? But maybe that's not what is very set to. So that's a comment from my side.
The circle that looks how this structure that you see and these elements when you put something across this point, they be the structure of this landscape. Because we are talking about putting this landscape, that's fine, although we just show it much clearer. But also it could be that these elements, they become itself the structural elements of this landscape that would be much stronger as a
and we have seen very evident that it could be done. Also, computationally. Somehow we're now looking at the very traditional landscape.
Yes.
Yeah, I do have a sort of commercial remark. And like I said, I'm quite familiar with the south part of Rotterdam. And quite typical for the south part of Rotterdam because the soils with the open declining very strong. So if you have a garden, and then the year after that they have to raise the garden for the soil because it's often lower. And that process will keep on continuing for the next 20 years or so. So if you could combine that data of all those gardens and etc. in the south area with your system, then one should not be so here. But on order for all those gardens in the south, that would be a perfect solution because it's a really big problem with is it inclining when the soil goes down? How it's legally well, the houses they stay up, but then the soil is sinking. So after a year, your garden is half a year old, and every year they have to raise the garden because the houses stay where they are. And that's really a big problem in the south part. And that could be, this could be the best solution to solve that. I give you my comment.
Comments, questions?
I agree with the comment. So integration. So integration is specific. So I think there's perhaps this opportunity to integrate back into the analysis into the production facility and mobility. So the strength of your proposals lies in the mobile. So power, let's say, is the opposite of something the mobile is. So in principle, the presentation could start with the parametric relationships and how those parametric relationships are interpret words, architectural, landscape, configurations. But of course, it's a great idea. I would advise you to push further.
As I said again, you were working on the script that provides the knowledge, software, what is the reference principle, but somehow it's not there. It's not shown to the public. Yes. I don't know. But okay, one last comment also from the structure.
I know you've been struggling with the concept and lost some time on that, so I think you have to develop something quite quickly. One of the things is the ramp going around it, basically close in air. So maybe we should discuss that too much, but can you comment more on the tower itself? So why is it a tower? And how does that relate, for instance, with the sun? So why did you take that shape? Because we have been discussing different shapes. You start with the tower. Is there a specific reason for that?
Yeah, just one reason is to optimize the amount of cubes and minimize footprint, basically, to be able to squeeze in more components and to be able to squeeze in build them up vertically, you need quite a service structure, I guess. So that's why we were stuck with towers. The main reason.
Okay, thanks a lot. Thanks a lot. So, thank you very much. Now we take a lunch break and we come back here at 1:45. Yeah. That's it.